LLMs, large language model. In this video, we are going to talk about large language models and we will see how these are created, what are the different architecture elements which are available when we create LLMs, and how these models are trained, what are the number of parameters, and how the tokens are counted. All these things we will talk in this video. Stay tuned, we will meet after a short intro. So friends, LLMs are large language model. In simple terms, these are machine learning models. Now, when we say ML models, it means it is trained on some data. And even before that, we have to create an architecture of that. So these are based on deep learning. So first of all, you have to understand what is deep learning. Deep learning is a ML branch in which we have mimicked how the human brain thinks and learn. It is based on neurons. So we have few neurons. It will get activated when it gets some right input, and as the output it will return something. So that's a whole new topic about deep learning. I will create a new video on specific on the deep learning, but let's focus on this video about LLMs. So LLMs are deep learning based models, and these models are trained on all the text. So these are NLP based algorithm. Not even algorithm, we should say model, because the simple traditional machine learning is based on algos. But here we are leveraging how the human brain thinks, that technology that we have built through neural networks. So LLMs are trained on huge data. When we say data, it means all the textual data. So it has the data on the internet, books, PDFs, right, which is available. So whoever creates a new LLM, they have to collect that data first and then train that model. And these models are trained through tokens. So now what is token? So token is a basic small entity which are used when we train the LLM. So if you have a text, then all the words in that text can be a token. But this is very simplistic definition I am telling. It's not just word. In a single word, you can have two tokens. And that is all defined when we are finalizing our architecture of the model. So let's keep it simple and understand each word is a token. So if you have a text or a paragraph and it has let's say 100 words, then those are tokens which act as an input for the model. And then as an output, it will return another text. And now what is text? It can be anything like summary, or it can expand it and explain it more elaborately, or it can create some title of that topic that you have given. So the original use case for LLMs was predict the next word. When we are typing on something, let's say on the Gmail, you might have experienced this. When you type something, a next word is automatically suggested. How it is done? It is done through this technique. They learn what user can type, and this learning happened through all the text which is provided during the training phase for the LLMs. Now, what took the emergence of LLMs is the one paper which was written in I think 2017, a transformer. The tagline was attention is all needed. So here when we say attention, when we are training the model, we are focusing on each word. So let's say in a sentence, if you have 10 words, then any word within that sentence, it will focus on other words also, so that it can find what is the probability of that word to be present at that particular place. So transformer has powered so many new models which are coming these days, whether it is in text world like LLMs, or it is image generation or video generation. All these things are powered through a transformer architecture. And within that architecture, when we look deeper, there is an encoder and decoder. These two components basically helps to take the whole input, which is a big text, then encode in some latent space, and then try to again produce that same thing through decoder. And now this encoder and decoder architecture has provided so many opportunities to create different applications using encoder and decoder. So it can be sequence to vector. Sequence means a sequence of letters or words, and then we can summarize it in let's say one word or smaller words. A sequence to sequence can be possible, and one use case is translation. Something you have written, let's say in English, and it can be turned into Hindi. That translation can be done through LLMs, which is an example of sequence to sequence. Another use case is vector to sequence. Here vectors can be like we have given a word and then it can explain it in elaborate sense. So it's a vector to sequence. And the new concept which help the LLMs to evolve is self-attention. And in simple terms, if I want to explain it, then I can say every word in the sentence will focus on all other words, which will basically then try to identify what is the right probability and what is the possibility that particular word should come. So these new concepts has led to the evolution of LLMs, and it is further increasing and it's developing its capabilities. One of the main thing that when asked about LLMs is size. So in a neural network, right, there are multiple connections, and all these connections have some weights which are learned during the training process. When these weights are learned, and these are called parameters, and as you grow your network, your architecture of the deep learning network, then in that case the number of parameters will increase. It means if you intentionally try to think, you have so many things to learn, but you can learn more perfectly because you can go deeper. But the challenge with this comes is the size of the models increases. It can even increase to like hundreds of billions parameters. So Palm 2, the Google's model is trained, is having 540 billion parameters. And when we increase the size, it's become very difficult to train that model and to contain all the things which is considered to be correct. And the challenge comes when we do some inferencing. That means when we use these models, it will take a lot of compute and memory, especially the memory, because it has to use those much of parameters in memory and then find the right words that is required. So if you use ChatGPT, like it generate right on the fly all that thing. So either there can be latency if we are not using perfect or up to mark compute, or there can be a memory things. So to deal such cases, there are multiple approaches that are advised. One is like train the model for a specific use case, reduce the size of the parameters, but for instead of building a general purpose model, you build for a specific task. So that can learn that particular task in a smaller number of parameters. Another idea is you can quantize that particular model. When we say quantized, quantization is basically a technique in which you will reduce the number of bytes which are taken for a parameter. So let's say a parameter, a weight, right? It is an integer. It will take 4 bytes. Now you can quantize it to 8 bits, basically 1 byte, right? But what is the side effect of this? It will not be that perfect now, because we are providing only 8 bits, 1 byte basically to learn that particular thing. So it depends on the use cases. If you want high accuracy, then you should go for 4 byte parameters, and if your use case supports can adjust with quantization, then I think you should go with quantized model. And definitely fine tuning for a specific use case is one of the good technique that should be considered when you are thinking of developing your own model. However, through the Gen AI, which is emerging, you can use these models, which are LLMs, which are hosted by the companies like Google, OpenAI, and Cohere. You can use those APIs and build some application logic on your side, and then you can serve your customer better. So I hope you got the idea what is LLM and what are the technology which is powering this LLMs things, and what are the different sizes of the models which are created, and what are the advised mechanism when we think whether we should train our own model or we should use our some other general provided models. So it all depends on the use case. Please let me know in the comment section what you are considering LLM for, and if you have any question, I'd be more than happy to answer. I can help you in your deciding what to use in your project. Let me know. So with this note, I'll take a leave. This is BK from Anika signing off.